going to look at this function. If y is equals to exponential times x, find dy all over dx. Amen? It's not difficult. I'm going to take it step by step so that you will understand it better. Okay, solution. Our y is equals to exponential times x. Yes, you know, these are exponential functions. How are you going to differentiate or obtain, find dy all over dx? If you can see what I am saying, this function, you are going to use substitution, and at the end you will use chain rule. How? Okay, let's do it together. At first, if I were you, you will now say, let's use P be equals to tan x. Amen? Okay. If P is equals to tan x, note that your y will now be exponential P. True or false? Yes, because you are using substitution. So now, your y will now be exponential what? P. Okay, let us differentiate this function with respect to P. Let's do it together. Our dy all over the P, it will still give us back exponential P. Is that clear? That is how it is. Okay, now, let us look at this function. We have P equals to tan x. Amen? Note, go back to your trick. Note that our tan x is the same thing as, is also equals to sin x all over cos x. True or false? Amen? Okay, so if you agree with me, it implies that our P will now be equals to sin x all over cos x. Is that clear? So how are we going to obtain our dp all over dx? It implies that we are going to use what is called quotient rule. Is that clear? So we now write using quotient rule to obtain our dp all over dx. Okay? We now write our dp all over dx and will give us u dv all over dx, amen, minus v du all over dx all over v squared. Are you following? Okay. So now, our quotient rule is just like our p is equals to u all over v. Amen? So compare it with this. Without one telling you, you know your x, you know your u, and you know your v. It implies that we now say let u equals to sin x and v equals to cos x. Amen? Okay. If you agree with me, we are going to differentiate these functions. We will differentiate this function and this one with respect to x. So let us differentiate sin x. Our du all over dx is going to give us cos x. Amen? And differentiate cos x. our dv all over the x will give us minus sine x. Are you following? So now we are going to substitute this into this formula. Is that clear? So now at this point, you know your ordinary u, you know your ordinary v. You know your dv all over the x, you also know your du all over the x. What's left is for you to substitute the answers into this formula. Our ordinary u is what? Sine x. Sine x. Then our dv all over the x is minus sine x. Amen? Okay? Then what do we have here? Minus. Minus our ordinary v is cos x. And our du all over, it will give us cos x. Then all over, amen, all over our v, ordinary v, is cos square, that is cos x all in bracket raised to the powers of what? 2. Okay? So if you can see what I am saying, you know very well that our dp all over the x, dp all over the x is going to give us, let us multiply out the two brackets, x, sorry, sine x times minus sine x will give us minus sine square x. Then multiply out these brackets, cos x times cos x will give us minus cos x cos square x all over cos square x, because this will give us cos x all in bracket raised to power 2 will give us cos square x. Okay, if you can see what I am saying, it's not bad. We multiply through by the minus sign. But before we do that, you know, sometimes one can even go for, instead of u dv all over the x, one can go for the formula, one can go for v du all over the x minus u dv all over the x all over v square. If somebody use this formula to differentiate this function, you discover that this numerator will be positive, if you can see what I am saying. Amen? Okay, for the sake of malleance, let's do it together. Let me still use this approach. Okay, so if we substitute in the x equals to our v, ordinary v is cos x, then our du all over the x will give us what? It gives us cos x, then minus our ordinary u is what? Sine x, then our dv all over the x will give us minus sine x. Amen? All over v square, which is our v, is equals to cos x. So cos x all in bracket raised to power 2. Are you seeing what I am saying now? So if we multiply out, because I want to do something, that is why I am introducing this one. If you multiply out, this will give us the p all over the x, will give us cos square x. Use this one, sine, let's bracket it first for the sake of malleance. Is that clear? Let us bracket it first. So if we use sine x to multiply minus sine x, it will give us minus sine square x. Amen? All over cos x all in bracket raised to the power of 2. Then if you can see what I am saying now, it implies that the numerator will be positive. Cos square x minus times minus will give us plus and sine square x all over cos square x. True or false? Okay. So if you agree with me here, now since I use this formula, we are going to multiply through by the minus sign. If we multiply through by the minus sign, we are going to have the same thing. Okay, let's do it together. Okay. So if you agree with me, our dp all over dx is equals to sine square x plus cos square x all over cos square x. Then note that intrigue, sine square x plus cos square x is going to give us 1. True or false? So our dp all over dx is equals to 1 all over cos square x. Amen? Okay. So now, you discover that I told us from the beginning that we are going to use quotient rule, acceptance substitution to solve this function. Then at the end of the day, we will introduce chain rule. Okay, so now we can now introduce our chain rule. Recall that our dy all over the p gives us what? Exponential p. Then our dp all over the x gives us 1 all over cos square x. So this implies that our dy all over the x is equal to the product of this. Amen? Either dy all over dp times dp all over the x. What is your dy all over the p? Is exponential p. Our dy all over the x is equals to exponential p times, what is our dp all over the x? Is 1 all over cos square x. 1 all over cos square x. Okay? Then, note that your p is equals to either, note that your p is equals to tan x. Amen? So our dy all over the x is equals to exponential tan x all in brackets, that is not all over cos x. Or this is the same thing as the x is equals to 1 all over cos x squared dot exponential tan x. This is the answer. Please like the page and share to your friends. Thank you and God bless you.